Hello, and welcome to the TechHub.training Python Determining Cost Drivers with Regression Challenge solution. This video solution includes using pandas and SciPy. With that, let's get started. I'm performing this challenge in Microsoft's Visual Studio Code. Feel free to use whatever IDE you would like, but this is what I use for this challenge. First, I imported the necessary packages, pandas, as PD, and SciPy, specifically the stats functionality. Then I imported my data. You would put your file path right here. And then for step one, we needed to calculate total overhead and total headcount. I did that by referring to the data frame, the manufacturing overhead column, and then using the sum method on both of these, and then printing out the driver estimate, which was calculated as total overhead divided by total headcount, which came out to exactly 1,000, as it said in the posting. Then I calculated it the other way, as given in the suggestion, by creating a new column called overhead per head and calculating the manufacturing overhead divided by the headcount column. This gives us the overhead rate for each individual production run, and then I use this print statement referencing that column and using the mean to calculate the average manufacturing overhead per head count per production run, and this comes out to 1138. I don't know which way is the better way to calculate this driver, but the point of this part of the challenge was to show that there is more than one way to calculate these things. For part two, we run the regression and then print out the output. The regression is run by using stats.lin, short for linear regress, and then you put in the x, you put in the x variable, and then you put in the y variable. These variables here match up with the linear regression outputs, and the order here does matter. So first is the slope, then the intercept, the R value, the P value, and the standard error. And I put HC in front of each of these because we're running the regression on headcounts effect on manufacturing overhead. So once we run this regression and print out all of these values, please notice that the R squared requires the R value to be squared using the star star 2 shown here. We see that we see the slope and the intercept outputs, but we notice that the R squared is really low. Even though this p-value is also really low, which is good, this R squared tells us that this model isn't very predictive. And so that's why we would like to run another regression later in this challenge. For step 3, I asked for you to run a regression between direct labor hours and total direct labor cost. And this follows the exact same pattern as the previous regression. And you'll notice here that the R squared is almost exactly 1, which is incredible. This means that this is a very, very predictive model. And that makes sense because in a situation where employees are paid on an hourly basis, direct labor hours will directly influence the amount that the company is spending on labor. So this is basically showing what an ideal regression, what an ideal driver would look like. And then for step 4, I said to run another regression and see if you could find something that's more predictive of manufacturing overhead. What I chose to use was machine hours, because machine hours impacts depreciation and other activities within the manufacturing process. And again, these variables are all put in the same order as the previous 2 regressions, and I print out the outputs the same way. We can see here that the R squared is 0.91, which is well above 0.5, meaning this is a reliable and predictive model. And this p-value, even though it starts with 6, this is really saying times 10 to the negative 267th power, meaning that this is almost exactly 0. This is a very, very, very small p-value. So this model, again, is very predictive and statistically significant. So machine hours would be a great driver to propose to Park's prediction. For step 5, we we used the regression to estimate the predicted overhead charges and compared those to the actual charges. I did this by creating a new column called predicted overhead and did the slope times the machine hours column, shown here, and then added the intercept variable that we created. And then I created another column called differences that takes the difference between the predicted overhead and the actual manufacturing overhead. And then use this print statement to print the average of those differences by using mean here. And the average difference between the predicted value and the actual overhead is 1.8 times 10 to the negative 14. So once again, this model is very predictive and statistically significant. A great model that you can suggest to the production manager. And that's the solution, and thank you for visiting TechHub.training.